Hello, pre-algebra students. This is chapter 6.3, solving proportions by using cross products. Every pair of ratios has two cross products. A cross product of two ratios is the product of the numerator of one ratio and the denominator of the other ratio. If we look at our example here, 3/5, 2 6/10. The cross products would be 3 times 10 and 5 times 6. Notice that for the ratios 3/5 and 6/10, the ratios are equal, and so are their cross products, both equal 30. For the ratios 2/3 and 6/11, however, our cross products are not equal, and either are the ratios. So in this way, we can use cross products to tell whether two ratios form a proportion. If cross products are equal, then the ratios form a proportion. If they are not equal, then the ratios are not proportional. Let's work through two examples together to tell whether a ratio forms a proportion. Let's begin with 9/51 and 6/34. We'll begin working out this problem by writing our cross products. 9 times 34 equals 6 times 51. Now, go ahead and calculate that out. Please feel free to use a calculator. This would be 306 and 306. So 9/51 and 6/34 do form a proportion. Here's another example, 12/20 and 32/50. Once again, we begin by writing our cross products. 12 times 50 is maybe equal to 32 times 20. 12 times 50 equals 600. 32 times 20 equals 640. So these are not equal. This does not form a proportion. Now try these four on your own. Tell whether the ratios form a proportion. Press pause while you work, and when you come back, we'll derive the cross products property. Now let's work to derive the cross products property. We can use the multiplication property of equality to demonstrate the cross products property. So let's say that A over B equals C over D. We're going to multiply each side by BD to remove our denominators. So BD and BD. We will divide out common factors, so remove our B's here and our D's on this side. This gives us AD equals BC. So the result proves our following property, which is simply that we can take A times D and B times C, which are our cross products, to find that AD is equal to BC, as long as A over B equals C over D, and neither B nor D are equal to 0. Now that we've worked through algebraically that we can use cross products to solve proportions, let's work through an example. Human hair grows about 0.7 centimeters in 2 weeks. How long does it take hair to grow 14 centimeters? So now we've just set up our ratios, and now we're going to use cross products property to solve for x. So we'll simply take 0.7 times x, or 0.7x, equals 2 times 14, which is 28. Now we divide each side by 0.7 to give us x equaling 40. So hair will take about 40 weeks to grow 14 centimeters. I skipped several mathematical steps there, so please let me know if you need me to clarify that process. Let's solve another. 18/42 equals 3t. So let's solve for t. 18t will equal 3 times 42, which is 126. Now we divide each side by 18, solving for t to give us 7. So t equals 7. Now solve for the variables in each of these proportions. Use the cross products property to solve. And now let's close out Chapter 6.3 with one final summary of all of the methods we've now learned for solving a proportion. One technique that we learned was to use equivalent ratios. If 5/12 is equal to x over 36, we simply need to find the multiplying factor. 12 times 3 equals 36, therefore 5 times 3 equals 15, and x must equal 15. So there we simply used equivalent ratios to solve. The next method is to use algebra. We're going to solve for x by multiplying each side by 36, so 36 times 5 over 12 equals x over 36 times 36. Our 36 is cancel on this side. On this side we cross reduce to get 1 and 3, giving us 15 equals x. So there was the algebraic technique. Finally, we can use cross products, which would give us 5 times 36 equals 12 times x, which gives us 180 equaling 12x, which is 15 equals x. All three methods give us the same answer, so you can truly use whichever one makes the most sense for your brain in that moment. Some problems work best with equivalent ratios, some work best with algebra, some work best with cross products. You may have to try more than one to figure out what works best for each particular problem. That brings us to the end of Chapter 6.3. I'll see you tomorrow to do more work with cross products.